Have you ever really stopped to think about the insane amount of complexity that's hiding in our most simple sentences? Well, get ready, because today we're pulling back the curtain on the secret rules your brain is using all the time. Rules that are so deep you don't even know they're there.
It all kicks off with this sentence that you've probably heard a million times. Most students came to the party. I mean, it seems totally simple, right? You hear it, you get it. But what you might not realize is that this little sentence is actually a really fascinating logical puzzle.
So let's just ask, what is this sentence really saying? Because the way our brains process it is so different from how a computer or some formal logic system would. And that difference, it reveals something pretty incredible about language itself.
Okay, to really wrap our heads around this, we need to try and see this sentence through the eyes of a cold, hard logical system. And that's where things start to get a little bit weird.
See, if you strip away all the context that our brains just supply automatically, a word like most becomes unbelievably vague. A computer might hear, most students came to the party, and think its job is to check most of the things that exist in the entire universe to see if they happen to be students who went to a party.
And yeah, that is completely absurd. We don't do that. Our brains don't start scanning the cosmos just to figure out what someone's saying about a party. It's kind of the perfect example of how our minds are running a much smarter, much more efficient program. But how? How does it do it?
Well, it turns out the answer is this powerful automatic process that we do without thinking. You can almost picture it like we're building a linguistic fence.
Okay, so this whole thing actually has a name. It's called Quantifier Domain Restriction. It sounds complicated, but the idea is simple. Words like most, every, or few, those are called quantifiers, and our language automatically restricts their domain, which is just a fancy way of saying it limits the group of things they're actually talking about.
So back to that fence idea. When we hear most students, our language instantly builds a fence around the relevant group. It just tosses out the entire universe of things that aren't students. Rocks, stars, kangaroos, whatever. It zeroes in only on that specific group of students that we're actually talking about.
And you can kind of picture it happening in these lightning-fast steps. First, you've got the whole universe of everything. Then a word like students or, hey, kangaroos narrows our focus down to just that category. And finally, the context of the conversation shrinks it even more to the specific group we care about. It's this super quick recursive calculation.
But here's the really wild part. This isn't just some clever shortcut our brains came up with. No, this whole process is actually governed by a deep, formal rule that seems to be hardwired right into the fabric of human language.
So this is not a random thing. It's totally systematic, totally predictable. It's a fundamental law of how we communicate, and it's one of the key things that separates natural human language from those more rigid, formal logical systems.
In fact, linguists have a name for this property. They call it conservativity. And get this, it's considered a semantic universal. That means it isn't just a quirk of English. It's believed to be a core feature of all human languages everywhere.
Okay, let's make this super concrete. If you need to check if the sentence most students are tall is true, what do you look at? Well, you only have to look at the group of students, right? And then see if most of them are tall. You automatically and correctly just ignore all the other tall things in the world. Tall buildings, tall trees, whatever. They're just not relevant. So, to put a fine point on it, that's what conservativity is. For any sentence that looks like most A are B, its meaning depends only on the group of A's. The rest of the universe, all the non-A's, they just don't factor into the equation at all. This is the engine that makes our linguistic fence building work. And this is where things get really cool, because this built-in efficiency puts our language in stark contrast to classical formal logic, which, has to play by a completely different, much more rigid set of rules.
Check out this classic example. If I told you all my unicorns are white, you'd probably just look at me funny, right? Because, I don't have any unicorns. In natural language, we just assume that the group we're talking about actually exists. But in classical logic, that statement is considered vacuously true. And it's true precisely because there are no unicorns to prove it false. How weird is that?
So, at the end of the day, these two systems just run on different operating principles. Our language is flexible. It's all about context, and it has this built-in assumption that we're talking about stuff that's actually there. The nouns we use aren't just labels. They create these rich categories, these types, that automatically guide our understanding in a way that logic just doesn't.
All right, so let's bring all this home. What's the big takeaway? What does all this hidden logical machinery really mean for us, in our actual lives?
Well, it means that every single time you have a normal conversation, your brain is acting like an absolute master logician. It's running all these complex calculations, restricting domains, applying conservativity, reading context, and it's doing it all in the background in milliseconds without you ever having to think about it. It's incredible.
And we're not talking about something you do once in a while. You are doing this thousands of times every single day. Anytime you hear some of the cars, or every single person, or a few of the books, boom, your brain builds that fence, instantly zeroing in on exactly what matters.
This whole system, it's the invisible engine that makes our conversations possible. It's what makes them so efficient and so full of nuance. Without it, every sentence we ever heard would be this impossibly huge, ambiguous puzzle to solve.
And you know, this is just one of these hidden rules. It really makes you wonder, right? What are the kinds of secret, elegant logic are just humming away right beneath the surface of every single word you say and hear?